Hello dear children, as we discussed, here we are to begin with exercise 3.6 from chapter number 3, pair of linear equations in two variables. So we'll begin with the first sum of exercise 3.6 and the question is, solve the following pairs of equations by reducing them to a pair of linear equations. So look at both the equations which are given to you, and if you just try to compare this with the standard form, it is clearly seen that they are not the pair of linear equations in two variables. So what we have to do at the beginning, we have to first reduce them or convert them into a pair of linear equations. So let's consider the first equation, 7x minus 2y upon xy is equal to 5. Now how to solve this? So what you have to do, children, we will separate every term and keep the denominator same to each term of this equation. Please have a look at this. So how will we write? First term is 7x upon xy minus 2y upon xy is equal to 5. Alright. Now if you see the first term, we can cancel this x and we can cancel this y. So what are we left with? We are left with 7 upon y minus 2 upon x is equal to 5. But for an equation, we always write x first. So we will write it minus 2 upon x plus 7 upon y is equal to 5. And we will number this equation as 1. Now let's consider the second equation which is given to us. Now here also we'll do the same thing. We will separate the term keeping the denominator same. So we will write 8x upon xy plus 7y upon xy is equal to 15. So you can cancel x. In the second term you can cancel y. So what are we left with? We are left with 8 upon y plus 7 upon x is equal to 15. And as I said, let's write the x term first. So we'll write 7 upon x plus 8 upon y is equal to 15 and name this or number this equation as 2. So look at this, children, the equations which were not linear equations in two variables, we have converted them into the simple form, but still equation 1 and 2 are not linear equations in two variables. So we need to convert them once again. So let's go ahead. These are the two equations which we got. So to convert this into linear equations in two variable, we will substitute let 1 upon x is equal to u and 1 upon y is equal to v. So what will be our equation 1 then? It will be minus 2u plus 7v is equal to 5, and we will number this as equation 3. And the second equation will become 7u plus 8v is equal to 15, and this we will number as 4. So look at this, equation 2 also we have made simple and converted it into linear equations in two variables. Alright. Now looking at this two equations, equation 3 and 4, now you can solve it either by substitution method or by elimination method. So let's see from equation 3, and this is what is our equation 3, minus 2u plus 7v is equal to 5. We can write 7v is equal to 5 plus 2u. From this equation we can get the value of v, and v is equal to 5 plus 2u upon 7. Now let's put this value of v in equation 4, and 7u plus 8v is equal to 15 is our equation 4. So we will have 7u plus 8 in the bracket value of v, which is 5 plus 2u upon 7 and is equal to 15. Now if you look at this equation, we cannot cancel anything, but our aim is we do not want anything at the denominator as well. So what will you do? We will multiply throughout this equation by 7 so that we can cancel the 7 from the denominator. So if you multiply this equation throughout by 7, that means we are multiplying every term of the equation by 7. So we'll write 7 into 7u plus 7 into 8 in the bracket 5 plus 2u upon 7. This is equal to 7 into 15. So now we can cancel our denominator, these two 7s we can cancel. So we are left with 49u plus 8 in the bracket 5 plus 2u is equal to 105. Let us simplify this. So we get 49u plus 40 plus 16u is equal to 105. Again simplify this. We get 49u plus 16u is equal to 105 minus 40. So 65u is equal to 65 and therefore u is equal to 1. This is what is our first value. Let's find value of v by putting the value of u in equation 3, and our equation 3 is minus 2u plus 7v is equal to 5. So we can write minus 2 into 1 plus 7v is equal to 5. So 7v is equal to 5 plus 2. 7v is equal to 7 and therefore v is equal to 1 is the value of the second variable, that is v. But our intention is not to find value of v and u. What we need? We want the value of x and y. We have substituted u is equal to 1 upon x, but we got the value of u as 1. So 1 is equal to 1 upon x, therefore x is equal to 1 is our first value. Similarly, we have calculated the value of v as 1. So 1 is equal to 1 upon y. So that will give us y is equal to 1 and this is our second value. And so we can say that our final answer is x is equal to 1 and y is equal to 1 is the solution of given equation. Alright, so look at this, children. The equation was so different and we have simplified it and got the values of x and y. Let's go to the next sum. So this is sixth sum from exercise 3.6. Alright, so question is 6x plus 3y is equal to 6xy, and the second equation is 2x plus 4y is equal to 5xy. If you look at both the equations, again these are not linear equations in two variables. If you compare this with the standard form, you can easily make this out. So let's reduce this to linear equations first. So let's consider equation first. This is what is our equation first. To take out this xy along with the constant term, what will we do? We will divide the whole equation by xy. So 6x plus 3y upon xy is equal to 6xy upon xy. Now let's make it more simple. So we will write 6x upon xy plus 3y upon xy is equal to 6 because we have cancelled xy. Alright, so here also we can cancel this x and y. So we are left with 6 upon y plus 3 upon x is equal to 6. And we will call this as our equation 1. Alright, so the given second equation, let's consider this now. We'll use the same method, divide throughout by xy. So 2x plus 4y upon xy is equal to 5xy upon xy. This xy we can cancel. So we are left with 2x upon xy plus 4y upon xy is equal to 5. Again cancel this x, cancel y. So we are left with 2 upon y plus 4 upon x is equal to 5. And this we will number as equation 2. So look at this, children, what was given to us and what we have converted that equation into. So these are our two equations which are still not in the standard form of pair of linear equations into two variables. These are not linear equations. So to convert this into linear equations, we will substitute 1 upon x as u and 1 upon y as v. So let's see what we get. So our new equations will be 6v plus 3u is equal to 6 and 2v plus 4u is equal to 5, and we have given the number as 3 and 4. To make it more simple, when you arrange the equations, you can write x term first and then the y term, and then you will get the equation in terms of u and v, first u and then v. Okay, so you can do that also. Now you can just make out that equation number 1, we have made it simple. Similarly, equation 2 also, and now these are two perfect linear equations in two variables. Now this we can solve either by, say, substitution method or elimination method and get the values of u and v, and after that you can find out values of x and y, and I'm sure you will be able to do that. So I have left the sum half for you to complete it. So this sum is your homework. Half we have done, you will complete this. Alright children? Okay, so we will move to the next sum. This is 8th sum, because 7th sum I have left again for you for homework, because it is similar to 6th sum. So we are starting with 8th sum. This is exercise 3.6, question number 1, and from question number 1, this is 8th sum. Now here if you see, again this is a different type of sum. Here if you see, the denominator of your first equation is 3x plus y, and in the second equation if you see, along with this similar term we have 2 extra there. The second term is 3x minus y at the denominator, and in the second equation it is 2 into 3x minus y. In both the equations we will see that two terms are similar, and for that term then we will substitute. So we will write 1 upon 3x plus y as u and 1 upon 3x minus y as v. So our equation will become u plus v is equal to 3 by 4, and equation 2 will become 1 by 2u minus 1 upon 2v is equal to minus 1 upon 8. Alright, so look at this. First equation is, we have made it very simple, and the second equation the same way. Alright, let's move ahead. So first and second equation we have written there. Let's cross multiply. So the first equation will become 4 in the bracket u plus v is equal to 3. So we get 4u plus 4v is equal to 3 as our new equation, that is equation number 3. And in the second equation, which we have made simple, there we are writing u minus v upon 2, because 2 is the common denominator, that is equal to minus 1 upon 8. So we'll have 4 into u minus v is equal to minus 1, and therefore 4u minus 4v is equal to minus 1. This is equation number 4. And just look at this, our complicated equation number 2, which was given to us in the sum, we have made it very simple as equation number 4. So you can see that equation 3 and equation 4 are perfect linear equations in two variables, which we are solving now. Now here if you see, we have written equation 3 and 4 one below the other. You can see there that the coefficients of v are similar and their signs are also opposite. So we will solve this by elimination method. So adding 3 and 4, we will first cancel these two terms. So we get 8u is equal to 2, and therefore u is equal to 1 upon 4. This is our first value. Let's put the value of u in equation number 3, and our equation 3 is 4u plus 4v is equal to 3. after substituting the value of u, we get 4 into 1 by 4 plus 4v is equal to 3. Cancel this 4, so you're left with 4v is equal to 3 minus 1, that is 2. So 4v is equal to 2, and therefore we get the value of v as 1 upon 2. But again, we do not want value of u and v as our final answer. We want the answer in terms of x and y. So let's see. We have taken u as 1 upon 3x plus y, but value of u we have calculated as 1 upon 4. So 1 by 4 is equal to 1 upon 3x plus y. So after cross multiplication, we get 3x plus y is equal to 4 as equation 5. And we have taken v as 1 upon 3x minus y, and we have calculated the value of v as 1 by 2. Again, after cross multiplication, you get 3x minus y is equal to 2 as equation number 6. So now we got our two linear equations in two variables in terms of x and y. Again, we have to solve it. Pretty lengthy sum, children. So many times we are substituting and calculating it. So these are our two equations. If you see, coefficients of y are same and their signs are opposite. So we will add equation 5 and 6 and solve it by elimination method. So first we will cancel this. We are left with 6x is equal to 6. So x is equal to 1 is the first answer. Put x is equal to 1 in equation 5. Our equation 5 is 3x plus y is equal to 4. So after substituting the value of x, we get 3 plus y is equal to 4. So y is equal to 4 minus 3. That will give us the value of y as 1. So x is equal to 1 and y is equal to 1 is the solution of given equation. Look at this. Such a complicated equation, and the solution is so simple. So here we substituted the values for the common term and we got the answer. Alright, so I want all of you to practice this sum in your book. Do not leave this sum just like that. This may come in the exam for 4 marks. So please practice this sum. This is an important sum. So all the sums which we have taken today are very, very important sum. Each and every problem was different. So please practice all the sums at home and write it in your classwork. Alright, we will begin with question number 2 of exercise 3.6 in the next video lesson. So see you all in the next period. Till then, bye and take care.